Welcome, everyone. I'm Venkat Rapaka. I lead the Android IoT platform team at Google. So being a part of the Android team, this is one of my favorite times of the year. We get to come to I/O, we get to interact with a lot of our developer community. A number of our partners also attend, so we get to meet all of them. But this year is especially exciting for me because this is the first time we get to talk at I/O about Android things and how we want to bring device production capabilities to more people. So you probably heard earlier today at the keynote that Sundar kicked off, Android now has incredible momentum across a number of verticals that you see up here. There are now 2 billion devices, 2 billion monthly active devices that run Android across these 4 form factors. And joining this family is now Android Things. And Android Things is designed to extend Android beyond these 4 verticals, mobile, wear, TV, and auto, to a lot more exciting new product categories within the space of IoT. And for us at Google, this is it's a very interesting area for us with all the innovation that's happening now. And we also see that there's an opportunity and a real need to enable developers to build high-quality, secure devices quickly and easily. And finally, I think there's an opportunity for us to democratize IoT device development and make it more accessible to more people. And Android Things was created last year as an acknowledgement of this potential that's ahead of us. So Android Things released in developer preview in December last year, and it's been great to see the excitement so far and the momentum we've built up. And in fact, we announced at the keynote this morning that already in just the 5 months up to now, there are thousands of developers in more than 60 countries who are actively trying out Android Things. So thank you very much for investing your time and all the feedback you've given us. So IoT, of course, is very broad and very diverse. Within this large space, Android Things is targeted at one of the most exciting, at least for us, one of the most exciting areas, powerful devices that sit at the edge and that bring on-device intelligence. And these devices span many use cases, both old and new. And you can see examples up on the screen. At the home, think of security systems, routers. They've been around for as long as most of us can remember. But also new, interesting device types like smart doorbells that have cameras built into them. In retail, increasingly you'll see point-of-sale machines, vending machines that have displays and that can interact with the customer's mobile device at the point of sale and do some very interesting things. When you think of smart buildings, which we talk about a lot, increasingly you'll have cameras in there. And these cameras can not only detect occupancy, they can actually do a head count and say how many people are in a given space at any point of time, and interact intelligently with other systems within the building, like the HVAC system, and do something smart with that knowledge. And finally, of course, truly mobile IoT applications like asset tracking, fleet management, these are all becoming much better every day with the ability to pull more context from the cloud and do something smart with it locally. When you look at all of these categories, you'll see some very interesting common themes emerge. One is, like I said, these are all very powerful devices. They sit at the edge. They perform some very complex operations, image processing, audio processing, and they do that all locally. There's a lot of on-device intelligence. And this is for a number of different reasons, or a combination of reasons. Sometimes it's for low latency. You just want to react very quickly. And other times it's for fault tolerance. Maybe your network is not as reliable as you would like it to be. And they all have a need for deep security, both at the device level, but also in how they interact with the cloud. But unfortunately, today, I think to build a device, any of these types of devices, is not easy. So let's talk about a few of the challenges that we see in this space that IoT developers face. Let's talk about the software part of it. So if you're a software developer, the amount of complexity that confronts you is massive. The IoT devices that you see today are built on a number of flavors of operating systems, whether it's Linux or Android. So it's very difficult to get a consistent and reliable sort of APIs that you can depend on. It's hard to find robust tools that you can use. And it's also very hard to find a community of developers that you can reach out to when you run into trouble. Think of all the basic building blocks when you're building a product. If you're building a product for a consumer application, even something as simple as a reliable setup flow so that the consumer can use their mobile device to set up the product you're selling them, as well as an app SDK that you can use to build your own app. If you think of an enterprise use case, having something like zero-touch provisioning and providing a console that the enterprise can use to manage their fleet of devices that may not even be coming from you, but a combination of devices that come from everybody. Or in some cases, providing them APIs that they can integrate into the console that they use. You have to build all of these from scratch if you want to get started. And finally, I think it's really hard to get access to third-party. Sorry, I'm too fast. It's really hard to get access to third-party services like the Google Assistant and getting them working out of the box, especially if you build multiple products in this space. So that's the software part of the problem. When you get to hardware, things get even more complicated, right? So not only do you have to first pick a number of components that you can assemble together to build a cohesive system, get your code running on it, and you do all of that just to get to the prototype stage, so just to do a proof of concept. But as you're doing this, you need to be really careful to make sure you're picking components that can scale to high volumes when you hit mass production. And if you don't do that, then you have to re-implement a bunch of work you did before to adapt to the new components that you're forced to replace them with. And this is not a problem that's unique to just small or medium companies. Some of our largest OEM partners tell us how difficult this is for them, even at the scale that they're at, especially when they think of this space with the diversity of product categories. And as they build out a product portfolio, they also struggle with this the same way that a small company would struggle. And finally, security. I think given the amount of security-related news that we see today, I don't think I need to belabor the point of how important security is in this space. But I think especially in the IoT scenario, it's much harder to deliver great security because of the scale and the diversity of the types of devices. To build a really secure device, but also to keep it secure over a period of time is incredibly hard. So with Android Things, our goal is to try and solve all of these problems for the developers. And we're doing it in multiple ways. One is by bringing the power of Android to help with software development. The second one is to provide a choice of hardware solutions that let you scale from a prototype to production with the confidence that you can do that in a quick and easy way. And then finally, we want to help you keep your devices secure. I want to talk a little bit about what I mean by the power of Android. In some ways, it actually cuts across all three of these themes. I mentioned the 2 billion monthly active users that Dave mentioned earlier today. But what makes that possible is a number of things. One of the most important of those is the people that are in this room, the developer community, the rich community that we have of Android app developers that make a lot of this possible. But also, we have a number of commercial entities, an entire supply chain composed of silicon providers, people who make various types of components, contract manufacturers, device manufacturers, retailers, and cellular operators, mobile operators. And it's a collection of all of these, all of you, that makes Android what it is, a very rich, diverse, vibrant ecosystem. And that is what we want to bring to the world of IoT. So let's start first with the developer experience and discuss how Android Things can make this very consistent and very familiar to a lot more people. What you see here is the software stack for a typical Android mobile device, a phone. Going from bottom to top, the kernel and the libraries are primarily focused on enabling hardware device support, hardware driver support. The middle stack, the application framework, provides a very rich services API for the apps, which of course are what a number of our developer partners and even Google builds to deliver a variety of user-facing services and use cases. This stack obviously is designed for devices of a very specific kind. Like all of them have a display. They all expect users to install apps. So there's a very specific notion that's built into these. And we all know that IoT devices don't exactly fit this mold. So we set out to create a variant of Android that's designed for IoT, which is what Android Things is. And one of the first things we did is we removed most of the user-facing applications and a lot of the visual framework components. So just as an example, you don't need a text messaging app or a browser on most IoT devices. I would argue probably on any of them. So while we did this to remove a lot of unnecessary complexity that developers face, one of the happy side effects was that we also significantly reduced the footprint of the distribution, which makes it a lot more scalable downward as you build IoT devices. Then we added a number of new capabilities that are relevant for IoT devices. And I'll touch upon a few of them very briefly. Let me start with peripheral I/O. Peripheral I/O is a part of the Android Things support library. And what it does is it provides new APIs that allow applications that you would build to interface directly with low-level peripherals using industry-standard protocols like GPIO and I2S and so on that you see up on the screen. And what this enables is that with these APIs, your application and your code can now interact with a number of peripherals like, think of simple things like buttons, relays, proximity sensors, more advanced things like displays and speakers and high-speed peripherals. And over time, we're going to add support for things like printers, barcode scanners, RFID readers, and so on. The second thing is the second thing is user drivers, which enables a very interesting use case for us. So in a lot of cases, your applications can just use the peripheral I/O. But in some cases, you may want to integrate your hardware with the Android framework so that you can access some of the standard framework managers and callbacks and expose these components and the capabilities thereof to other applications that might sit on your product, applications that you might get from a third party, for example. So again, as a few quick examples, input devices that generate key events or motion events can now inject those events into the Android input framework. Or think of GPS or other location sources that you attach to your product, and this can be integrated with the location framework, Android location framework. And once you do that, location updates from these sources will then be delivered through the location manager and the Fuse location providers. So over the last 5 months, at Google, we've been adding drivers on our open source community GitHub page for many different types of peripherals. And we've noticed that a lot of our developer partners are beginning to contribute as well, which is really awesome to see. And increasingly, some of our partners are also getting into the act now. Just as an example, Intel recently added support for Android things with their useful packages and modules and MRAA, which brings with it about 200 very interesting components and peripherals that now work on Intel Joule and Intel Edison when you use Android things. I mentioned we removed a lot of the visual framework components. And we did this because a lot of IoT devices don't have displays. But at the same time, there are definitely quite a few that will have a display, sometimes more than one display. So the way we think about this is that display support is optional, right? So you can add a display if you want. And Android Things supports the same UI toolkit that's available in all the other Android form factors. So you can rely on the same framework. So if you build a device with a display, the entire display, the control for the entire display is actually handed to your application that you build. And what we did is we basically got the system UI out of the way. So no more system status bar, navigation buttons. We eliminated a lot of the APIs that don't make sense, like showing a dialog for authentication or sign-on, Android system notifications, user-granted runtime permissions. So we removed all of these. And we believe this more closely mimics the types of devices we encounter in the IoT space, where the devices tend to be fixed purpose, and the users interacting with the intended purpose as opposed to adding new functionality through the display that's on the device. Moving on, let's talk about connectivity a little bit. Today, already in the developer previews that we released so far, we support Wi-Fi and we support Bluetooth. We are going to bring NFC later this year. But the one I'm very excited about is cellular. So adding cellular capabilities to IoT devices unlocks a variety of very exciting new use cases. But adding cellular support is non-trivial, as anybody in this room who's tried can attest to. And what you'll find is that half the challenge is actually enabling the functionality and making sure it works. The other half of it is getting it certified to work on carrier networks, especially if you have a geographic footprint that goes beyond one country. That challenge goes up dramatically. As it turns out, the core Android team, which we're a part of, works very closely with a number of silicon partners in the context of mobile phones to deliver this capability. And as it turns out, we're working with some of the same partners very closely as well. So we're going to leverage a lot of the work that the core Android team does to bring cellular connectivity in a very clean, easy-to-way use onto Android Things over the course of this year. In fact, Qualcomm earlier this year announced that they're going to support Android Things on their Snapdragon 210 processor that also has an LTE modem capability. So I talked a lot about the changes we made and the things we added. Let me now talk about the things that we did not change, which is the core power in the ecosystem that Android brings with it. So you can still continue to leverage the Android SDK and the NDK, Android Studio to develop your use cases and your APKs on top, and all the developer tools that we provide you. You can continue to use the existing third-party Android libraries. And as importantly, you can continue to tap into the rich community of Android app developers for support and to also reuse things that others build, right? So So that's one of the exciting things that I think Android can bring to Android things. Play services. So Google Play Services has a number of very interesting APIs that people rely on. This is currently already available in Android things in developer preview. What we are currently working on is an optimized, much lighter weight version of Play Services that's targeted at IoT devices that we're going to deliver later this year. So what we did is we removed a number of APIs that we thought were not useful in this space, things that enable user input or user account management, which don't necessarily make sense in IoT. And by doing that, we reduced the footprint of GMS core by a lot. But we preserved APIs like Firebase. And we're adding enhanced APIs that support machine intelligence on device. And of course, I mentioned Firebase, incredibly valuable tool in this space. We're going to continue to support that as we build out Android things. The ability to access Google Cloud Platform if you need cloud storage and additional compute. And we'll make that seamless as well, that integration. And then a lot more, right? Like, so even yesterday when developer preview came out, the Assistant SDK, we provided a sample yesterday that lets you build a Google Assistant prototype using Android things, right? So, and you'll see a lot more Google services and apps that we're going to bring to Android things in a cleanly integrated, easy to use, modular way, meaning you can pick the ones you want. So when we put all of this together on the software side, what you get is, if you're an Android app developer, all of a sudden this opens up the world of IoT devices to you, and you can set out on a path to be an IoT device developer yourself. If someone with an idea and you want to go build a device, you can actually tap into this community of Android app developers, and you don't have to build a full team of deep OS experts any longer to even get started. You can actually pick some of these things that we're building and tap into this large community and get going. Finally, we did talk about devices getting increasingly smarter, and I'll talk a little bit about how we are making that happen. So on-device intelligence is going to be critically important in IoT over time, and this can be for a number of reasons. One, I mentioned before, latency, right? You might want a very quick response time. You might have bandwidth constraints. Bandwidth is expensive sometimes. Your connectivity might be very unreliable, and so on, right? So with Android, the core Android platform itself, and also with Android things, we're making, as a collective, we're making deep investments to bring on-device intelligence capabilities in a very deeply integrated fashion into the distribution we're going to provide you. And earlier this year, we added support for TensorFlow on Android things. And it's been awesome to see some of the creative things that our community has been already building so far. And at our demo space, you can see TensorFlow in action. There are two demos, one that our team built, another one that somebody in the community built using the pieces that the components we delivered already. There's also a code lab for TensorFlow that you can go and get your hands on it. So I'm going to switch gears a bit now and move from software to hardware, and how Android things is going to simplify and accelerate your hardware prototyping process as well. So if you're getting started on a new device, as I mentioned before, you need to assemble all the right components. You need to make sure they all work together. Your proof of concept works. Then you have to procure all these components at scale at a price that you're able to pay. And then that's when you get to mass production. And there's a lot of complexity involved in this, and a lot of time as well. So to help with this, Android things uses something called the System on Module architecture, or the SOM architecture. And I think a lot of you in this audience are probably familiar with this concept. A SOM basically has a core computing module. So it has compute, connectivity, storage, and many other core components in a very small package. And when you're building an IoT device, some of the most complex hardware design is actually already encapsulated in the SOM itself. And what you see here on the left side, my left, are two modules, one from Intel, one from NXP that we already launched. And in close collaboration with our silicon partners, we're going to provide a BSP, a board support package, that basically provides a very clean layer for your code to reside on top of. And what that does is it makes your code very portable to other supported hardware platforms as you build out a portfolio of more capable devices within the same category, or you're switching to a new category and you want something quite different. So let's see how a SOM is in action. So it's pretty hard to see on the slide how big these SOMs are. So the smaller image you see up there is this. This is what a SOM looks like. It's about an inch and a half on the side, roughly a square. And the larger image there is the baseboard that we use internally. It's a photo of a baseboard that we use internally. It has the kitchen sink of all the peripherals and connections that we need for our own internal prototyping and development and testing. And of course, the product you build won't require all of these components. So you would have a baseboard that's much simpler and only have the things that you need for your product. And baseboards typically tend to be a lot less expensive to produce even at lower volumes. So your prototyping becomes a lot easier once you start using a SOM. And the SOM model, we believe, offers some very key advantages. One is you can get to prototype stage much faster by taking off-the-shelf components. And the pre-certified hardware basically reduces not only your time to market, but also your development costs, and also takes out a lot of the technology risk inherent as you're building your prototypes. And of course, as you scale to larger commercial volumes, you can be confident that you can procure this in high volume. And if you hit really high volumes, you can actually collapse the baseboard and the SOM into one board. And you can get a custom board built for you. And it has a couple of advantages. One is it can reduce your cost. And the other thing is you can then lay it out in a way that matches the XY dimensions of your product, right? So you can actually optimize it to fit exactly cleanly into the product ID that you want to build. And as long as you use the same BSP, you don't have to rewrite any code that you already built. If you want to learn more about SOMs and how to build custom BSPs, custom boards, I think there's a more detailed talk coming up tomorrow at 9:30 a.m. So, of course, you need SOMs that can match the price and power and performance and connectivity needs that your product has. So to do this, we're working with a number of industry leaders to make sure you have plenty of hardware choices. Today, we already support boards from NXP, Intel, and Raspberry Pi. And Qualcomm, as I mentioned, announced earlier this year that we're working with them on the Snapdragon 210 line. And we're also working with MediaTek to bring an option from them as well with Android Things support on it. Finally, I'll talk about security. So thankfully, there is now an increasing focus on security in IoT. And in the IoT space, the challenge is dramatically higher for a number of reasons. One is just the diversity of the device types, the diversity of the operating systems and the hardware that's underneath and the use cases. But also just think about how these devices are used today, right? A lot of them operate with no user intervention or interaction. There is no display where you can say something to the user. And a lot of them are out of sight, out of mind. I can't remember the last time I looked at my Wi-Fi router, which is sitting in a closet under my stairs. So not only is it hard to build a device that's secure when you launch it, it's also really hard to keep that device secure over a period of time. And Android Things has been designed for security from the ground up. And what you see here is two separate parts of the code. One is the OS that's provided by Google in close collaboration with our silicon partners. And what you see at the top is the product-specific code that's created by the app developers. This is your apps, your user drivers, and so on. And separating these two is a very clean Android API layer. And what that allows us to do is update either of these two partitions independent of the other without compromising the functionality of the product. So it allows us to push updates to either of those two partitions. So I talked about security updates just now. So the Android team, which we're a part of, invests a lot of energy into delivering monthly security updates, which we're now going to bring to the IoT space, to Android Things. These partitions are signed by a trusted source for security. Android Things supports verified boot, so that your device is protected against a corrupted image that you might download, and it's going to block your device from booting into an unknown state with an image, maybe that signature that you don't trust, or the contents you cannot verify. There's also AB updates, which lets you roll back. So if you push something out by accident that compromises the functionality, there's always a known good image on these devices so that you can, without having to do something in the field, revert back to a known good image and boot the device back up and recover from there. And to push all of these updates and to give you the control on rollbacks and to also monitor your fleet of devices, we are building currently a developer console that we're going to give you access to soon. And this same console that's going to be built on Google infrastructure, you can use that to push updates to your partition as well. So as you come up with security patches or you extend the features and functionality of your partition, you can use all of our infrastructure to push updates. So it gives you the ability to make your devices better over time. using the Google backend. So again, to quickly summarize, with Android things, we're going to bring the power of Android to simplify software development. We're going to provide you a choice of hardware solutions that are going to allow you to scale from prototype to production easily and quickly. And then we're going to help you keep your devices safe and secure. Let me talk a bit about where we are now. So Developer Preview 4, DP4 shipped yesterday. We added a number of new capabilities like I2S support that lets you connect up external audio devices like speakers, for example. We also added a new SOM, the IMX7D, which delivers higher performance than the 6UL that we already have support for. And also, I mentioned the Assistant SDK sample that we delivered, so you can prototype a Google Assistant, a Google Home-like product for yourself using one of our SOMs and Android things. In July, we're going to hit Developer Preview 5. We're going to rebase to O at this time. And we'll have a number of new features, of course. We're also going to launch the Developer Console into preview mode at that time. And later this year, we're going to have a number of new features coming. We'll have updates, Developer Preview updates every 6 to 8 weeks, roughly. We'll have the GMS Core for IoT variant that I mentioned before. We're going to have new features like NFC support and smart setup with matching app SDKs. We're going to have a lot more SOMs coming from some of the partners that you saw just now. And finally, towards the very end of the year, we're going to release Android things to long-term support, and it's going to be based on O at the time. So you'll have LTS release of Android things then. We're also going to release a lot of the Android things features like peripheral I/O and user drivers to AOSP as well. So tomorrow we have a number of interesting sessions coming up that go a lot more into depth on some of the topics that I just briefly touched upon. So these are all the sessions that are coming up. So if you want to learn more, please go attend them. We also have a demo area in the IoT Sandbox Dome where you can see TensorFlow in action, like I mentioned. We have several code labs where you can get your hands dirty. You can see how Android things can work really well with the Google Cloud. So there's a lot of things that you can do at I/O to learn more about what we're up to and where we're going. There are additional resources, of course, beyond I/O. I'll go in order. The very top link is a link to our Google Plus community of developers where our community can come to us to get updates from us, to get support from each other, as well as our team. We're pretty active on the community now and answer questions when needed. The middle link is a link to Google's broader IoT page. It covers our entire spectrum of IoT offerings. And the last one is our developer documentation page. And it has a number of resources, including code samples that you can try out. So this concludes our talk. Thank you, everyone, for coming.